Hold it! Stop the movie! Now look here. This film is under quarantine due to an outbreak of tuberculosis. You'll need a hazmat suit, gas mask, oxygen tank, antiseptic gloves, biohazard bags, disinfectant spray, and microbicidal pantaloons. Alright, go ahead in. Alright, you can skimp on the gas mask. I mean, it's just a cartoon.
Microbes are organisms too small to be seen with the naked eye, including creatures such as bacteria, viruses, fungi, and microscopic parasites. Collectively, they are quite literally everywhere, thriving on most every surface in most every environment. A variety of bacteria even prosper on and inside the human body, helping us digest food and keeping out foreign microbes. Of course, they don't care what happens to their environment, be it test tube or intestines, so long as they're thriving. Sometimes this can result in good, like with industrial microbe use, but you're probably more familiar with the bad. Pathogens are microbes that cause disease within a living host, from the irritating common cold to the devastating tuberculosis. Food and drink are their preferred avenues, but be it sandwich, soda, or surgical tools, they will take advantage of any opening possible. And of course, pathogens will not hesitate to pose threats within the environment itself. Now the role of microbial control is evident, to stop microbes from getting into places they aren't supposed to be. The standard of control is the incapacitation of microbes, but the approach to this can vary according to the situation. So for each occasion of microbial control, keep these 4 possible outcomes in mind. The first outcome is sterilization, the complete eradication of all microbial life. Fun, right? Extreme heat is the most common application for achieving this, and is used most often on biocompromised surgical tools. The second outcome is disinfection, which is the eradication of most microbial life, with the exception of endospores, extremely durable structures that bacteria spawn during their dormant life stage. This outcome can be achieved through immersing items in boiling water, and is suitable for many household applications. The third outcome is antisepsis, which applies disinfection to living tissue, such as through using rubbing alcohol on a wound. Antisepsis is unique in that the target is usually a human body, and should ideally be protected, regardless of how much the alcohol stings. The fourth outcome is decontamination, the separation of microbes from a substance, such as by air and water filters. One mode of decontamination is sanitization, in which soap or detergent is used to reduce contamination. Of course, there are concerns in the field of microbial control. For instance, how can we tell if organisms that small and simple are really dead? The fact is, microbes have no real vital signs. For them, the most accepted definition of death is the permanent loss of their reproductive functions.
Well, that's the last of them. Good job, buddy. You kept quiet the entire time.
Hello friends, welcome to Biology for All. Myself Ikramul. Today I will discuss what are the difference between cleaning, sanitization, disinfection and sterilization. These four terms are very often, but there is the difference between them. Keep watching this video till the end. I will discuss step by step. If you are watching this video in YouTube, please subscribe our channel. If you are watching in Facebook, please follow our page Biology for All. Let's start. First, talk about cleaning. Cleaning is the first and most important step for controlling the spread of infectious germs. Cleaning simply means the removal of dirt and impurities from the surface. In cleaning, physically remove microorganisms from the surface. This process do not necessarily kill germs, but by removing them, it lowers their numbers and risks of spreading infections. Some common examples of cleaning agents are soap, detergent, etc. Now come to the next point is sanitization. Sanitization is another word of cleaning. It reduces the number of microorganisms to safe level. What are the difference between cleaning and sanitization? Cleaning means that the dirt and impurities are visibly removed from the surface. When items are sanitized, it means that the surface have reduction of pathogen. There still may be microorganisms present, but they are at safe level. Now come to the next point is disinfection. Disinfection, it reduces the vegetative pathogen but not bacterial endospore. Some common example of bacteria, those produces endospore, such as the Bacillus, Clostridium, etc. Disinfection work by using chemical. Some common example of disinfectant are 70% isopropyl alcohol, Lysol, Pyrosil Pharma, etc. Disinfection can apply only on inanimate object. What are the difference between inanimate and animate object? The inanimate object are simply means the non-living object, like the table, chair or any other surface. And animate means the living tissue or living surface. And now come to the next point is the sterilization. Sterilization is the complete removal or destruction of all viable microorganisms. Sterilization is done by many processes. It is done by exposure to physical and chemical agent, by filtration. The most common method for sterilization is done by autoclave sterilization.
begin by discussing the basics of healthcare environmental cleaning and disinfection. Cleaning is the physical removal of visible dirt, dust, and organic matter. Disinfection, on the other hand, kills nearly all disease-producing germs called pathogens. Surfaces must be cleaned before they can be properly disinfected. Disinfection will not be effective in the presence of dirt, blood, or if other contaminants remains on the surface. First, perform hand hygiene and apply personal protective equipment referred to as PPE. Begin by cleaning from the highest area to lowest and moving from the cleanest area towards the dirtiest. Move in one direction around the dialysis station as you clean. This method helps to reduce the risk of cross-contamination. Next, perform hand hygiene and apply gloves before cleaning the patient station. Designate sets of cleaning cloths or disposable germicidal wipes for each patient station. Use microfiber cloths and mops when available. When cleaning, clean from highest area to lowest, and from the cleanest areas moving towards the dirtiest. These practices, along with moving in one direction around the dialysis station area as you clean, will help to reduce the risk of cross-contamination. When using a disinfectant cleaner, wet the surface, use friction to clean, and allow to air dry. Fold the cleaning cloth in a series of squares to provide a number of potential cleaning surfaces. A wadded cloth does not clean efficiently. Replace cloth as needed. More than one cloth may be required for a patient station. Never use the same cleaning cloth for more than one patient station. Never re-dip a used cloth into clean disinfectant solution. For cleaning areas,
then she begins to clean, making sure she is going from top to bottom, cleanest to dirtiest areas. Then she moves in a clockwise, counterclockwise fashion around the room. This helps her to clean all items that need cleaned and also to prevent her from cross-contaminating areas and items in the room. Anna folds and refolds her microfiber cleaning cloth that is dampened with the approved disinfectant as she moves around the room cleaning. This process also helps prevent cross-contamination by making sure the cleanest portion of the cloth is used as she cleans. Use of microfiber cleaning cloths is considered a gold standard in healthcare environmental cleaning by infection control. The technology of microfiber cloths greatly increases the germ removal ability over non-microfiber rags. Anna changes her cloth frequently when needed and never touches a dirty area of the room with the same cloth that she will use to clean a less dirty area. She will clean the bathroom last, since it is considered the dirtiest area of the patient room. In the bathroom, she begins with high to low cleaning and then moves from the cleanest area. For example, that includes the sink toward the dirtiest one, which is the toilet. The last thing she will do after cleaning and disinfecting the toilet is to mop the floor with a disinfectant. Anna has a very... You must remember that dust is not our friend in healthcare. Dust carries germs through the air, in the air currents, and can increase the risk for infections. Our goal is to prevent dust movement during the cleaning processes. You should never use dry methods such as feather dusters or other dry high-reach types of equipment to clean and dust in patient areas in healthcare. Instead, use a damp dust method. To do this, the cleaning cloth, microfiber mop, or microfiber duster is dampened with the approved disinfectant, and then the surface is damp wiped clean. Remember to dampen, not saturate. Also, don't forget to use friction when cleaning, as this is very important in the germ removal process of cleaning in healthcare.
When incidents involve blood or other bodily fluids, staff should follow the disinfecting protocols outlined in a school or district's blood-borne pathogen training.
Proper glove removal. Follow these steps to prevent the spread of pathogens. Pinch the first glove at the wrist and pull down, touching only the outside of the glove. Ball up the removed glove in the palm of your gloved hand. Slide an ungloved finger inside the other glove, touching only the inside with your ungloved finger. Peel the second glove off inside out, trapping it in your palm. Discard the balled up gloves in the proper receptacle. Clean your hands with soap and water or alcohol-based cleaner.